Hey guys, my name's Noel. I'm back with segment 3, my Synergetics and the Unified Field. The importance of this work is that I'm explaining some mysteries in physics which people don't understand right now. Frank Close on page 39 of a book he wrote called Particle Physics. He's a teacher of particle physics. He says, the full details of how the mass of the proton turns out to be precisely 938.4 megaelectron volts is beyond our ability to derive from theory at present. And I know that actually it's calculated today at 938.27. Just getting into some interesting facts, you guys. Feynman, he's real great. He says, you know, this number 137, or actually 1 divided by the second root of 137, which is the amplitude at which an electron absorbs a photon. This number 137 relates also to the ratio of the speed of light compared to the electron's velocity around a hydrogen atom. The electron around the hydrogen atom goes approximately 1/137th the speed of light. Feynman says, now this number 137 has been a mystery since it's first discovered. Every good physicist should put this number on their wall and worry about it. It's one of the greatest damn mysteries of physics. So physicists are doing some incredible calculations with what we're discovering within the Large Hadron Particle Colliders regarding the masses and mega electron voltage of all these different particles, but they're not understanding how it developed. Feynman said, you know, it makes no sense for us to blow up a Swiss watch and then try and find the pieces, and by looking at just a few of the pieces, try and discover what it was and how it worked before. Buckminster Fuller, he says something similar. He says, you know, blowing up a 747 and then looking at all the blown up pieces, there's almost no way for us to take one of these pieces and one of these pieces and be able to say, oh yeah, these go together like this and it makes a 747. What I'm finding then that's very interesting is that I've hypothesized from our previous scientist, Planck, who says actions come in whole units. You can't have a half of an action. You can't trip and fall half the time. You can't crash your car a third of the time. You can't break your leg, 0.72157 times. So in my system here, everything begins from the singularity. We'll call it that Big Bang, that hypothetical, where did everything come from? And this infinite expansion then is modeled by my graph and charts that I show in the other one I'll show briefly in a minute here. The charts then which show the total number of closest packed unit radius spheres, their kissing points, which indicate also their total number of vectors. A vector is from the center of volume of one sphere to the center volume of the other sphere. As I explained in my other videos, the spheres can disappear and the vectorial interconnections will still maintain their structural stability because of self-stabilizing intertriangular principles which occur when energy vectors and tensors hold at vertex points energy patterns in polyhedrons, which will create bigger and bigger polyhedrons. Bucky says proofs must proceed from the minimum structural system to universe and the differentiation out of universe of the special case conceptual system. What he's talking about then is we've got to start with that first thing that we can imagine in universe. And that first thing is the first insideness and outsideness in universe. It's called the tetrahedron. The tetrahedron is beautiful because it's one of the only polyhedrons which has symmetry when its face is shaved off. I'm going to show you real quick, Christian, if you could. You'll notice this is a 6-frequency tetrahedron. I've talked about this in some other ones. Get it right here if you can. You'll notice that if you cut this frequency off, the 6th frequency is the exact same shape, just a different size. And it continues ad infinitum. If you shave off the face of an icosahedron, it's no longer an icosahedron. Shave off a regular icosahedron. It's shave off a face of the octahedron, it's no longer a regular octahedron. Different edge lengths occur. Same thing with all of the rest of them. Cubes faces, tetrahedrons faces, etc. So I hypothesize then, because he also says all of the geometrical and numerical values that we derive come from fractionation of the whole. We take whole universe and we take special case conceptual scenarios and then we start fractionating them. We're doing that in Large Hadron Colliders right now, and then we're trying to find out which pieces of our fractionation are going together in whole rational units, kind of like how Planck thought. Now energy doesn't necessarily come in whole actions because we measure it in our own certain way. But you could imagine that an energy pulse or quantum of energy does come as a whole unit, just like hypothesized with the photon from Einstein. Now Einstein, he starts studying and he says, you know, the universe, it's finite, yet unbounded. He sees that radiation expands omnidirectionally away from the center of gravity. And so in our system, what we do is when we see these polyhedrons expanding, we don't see them getting bigger on one side. We see them expanding centrally, where balls phase into spaces and volumes within the interior, and then back into balls, or spheres to balls, spheres to balls, spheres to spaces. These transformations can be seen in synergetics. Very interesting. The new geometry which developed. I still remember some cool commercials back in, I guess I'm in 75, 76. I was maybe 10, 11 years old. Study the new science of synergetics. It was really pretty cool. My parents got a book and it sat on the bookshelf for a long time. Until I spoke with Arthur Young, a friend of mine. I should say friend, I met him a few times. Great guy though, you know, we were having a conversation and it led to the unified field. And I asked him, I says, you know, Arthur, if one wanted to find the unified field, where would one look? Now that was like 27 years ago, so the youth, you know, of our age, asked some cool questions. And he pondered it seriously. He said, you know, I think a good place to start looking would be Buckminster Fuller's Synergetics. Do you know this work? And I says, yes, you know, we got a copy at home. So he encourages me to study his work, The Reflexive Universe and the Geometry of Meaning, saying to me, I wrote these books for you and the other laymen, people who are interested in this subject, but they're not let through the doors of academia. So it was just coincidence that 25 years later, I pull this old book, Synergetics, off the bookshelf and study it. Because I'm bored, and it's interesting. I'm like, well, this is really interesting. And this Bucky guy, he's talking about all kinds of atomic physics and nucleus and protons and neutrons, and I realized he's being serious. This is cool. It's a different understanding of the makeup of atomic structure. Bucky says if physicists want to understand how universe designed atoms and combinations of them, all they need to do is study synergetics. Now, I took him at face value, and that's why I drew up these charts, and I understood how an expanding universe, which expanded omnidirectionally, symmetrically, for some certain amount of time, hypothetically, now that Big Bang expanded to the size of our current galaxy in like 1/4,000,000th of a second. Well, that's faster than the speed of light. And I'm not going to go into that because they don't understand that. These are just theories that we have. So what I do then is, look, I expand universe. Check this out, right? Universe expands, and I say to myself, when's the first time? Go ahead and look at me. When's the first time that universe can fraction itself in whole rational units by 1/137th? I say it has to be 137 big, right? So we calculate 137 frequency. If you don't understand frequency by Synergetics, please watch my other videos. At the 137 frequency measure, we come up with really cool, interesting stuff. When you fractionate 1/137th of the tetrahedron at 137 frequency, you get the 136 frequency measure. And that polyhedron breaks up into interesting number patterns. Those vectorial interconnections I told you about, they're all an exact number. Like, see this? There's no half vectors or sticks in my model. There's no half balls or no half spaces. They're all exactly whole units, rational, ratioed one to the other. So when you take that polyhedron, it has exactly 9,384 vectors times 137 times 2. Seems to me like now we see how universe's basic ratioing metric has created a ratioing metric with ratios 9384 in whole rational units to 137. Now, I followed this system out really far to see what happened when you got to really high numbers. I believe that physicists currently do have, I know for a fact that they do have the formulas for the total number of closest packed unit radius spheres in these various polyhedrons. I discovered them on my own and only later realized that they had them. Then I was studying some other books. There's a really cool book by a man named David J. Wales. He's a professor of chemistry over in Oxford. He wrote a wonderful book. It's called Energy Landscapes. In Energy Landscapes, he talks about how then the energy of molecular structure can ratio itself to these various polyhedrons using these formulas for closest packed unit radius spheres. Now what's important, especially after I read Mr. Wales' work, is that I saw then that nobody on the planet Earth has these formulas. We're going to show these formulas real quick. I'm just going to explain them. What happens then with these formulas then is these are the vector connections. which I haven't seen anywhere, published anywhere, looked at online anywhere. Come up close, I'm going to explain all these real quick to them. So the total number of vectors that occur in an octahedron is measured by frequency to the third power times 4, plus frequency to the second power times 6, plus frequency times 2. The total number of vectors in the vector equilibrium equal frequency to the third power times 20, plus frequency to the second power times 12, plus frequency times 4. Vectors in the cube are 24 times frequency to the third power, plus frequency times to the second power, times 12. Total vectors in the tetrahedron, 96 times frequency to the third power plus 42 times frequency to the second power plus 6 times f. Vectors in the truncated tetrahedron, which I also call the 23 pump, I can explain that in another video, 23f to the third power plus 21f to the second power plus 4f. Total number of vectors interconnecting these spheres, which spheres can disappear, and the vectors still maintain their structure, the tensile integrity. So what I did was I said, well, what happens when this fractionation process happens the second time and the third time and the fourth time? So what I did was I just continued to fractionate universe in whole rational units of 1/137th. And this is what I noticed that's real cool. Please. When you have 137 times any number plus a number, it's always going to be divisible by 23. 137 times any number minus that same number, it's going to be divisible by 17. What this does is it starts up a basic metric. Wherein first it's 137 times 1 plus 1, and minus 1 is 136 and 138. Keeps going wherein the ratio differs. I go over this in my other video, so you're going to have to watch that if you want to really follow along. I apologize. But physicists understand then when this just basic mathematical rhythm goes up, it meets at 9384. So that's how the fine structure constant and the proton developed in perfect symmetry when the universe began to expand. Now, this number also breaks up very interesting. It breaks up into 729 plus Planck times 10 to the 34 times 2 to the third equals 782. Which is the free neutron's binding energy, 0.782 megaelectron volts. Remember, I only use whole rational units. We don't have points of anything. There's no, a half of anything that happens in my system. So it's just very interesting. Notice how the proton's kinetic energy is 17 electron volts and how that's part of this whole mix. So I said, what happens at other numbers? Does 17 and 23 revolve around any other numbers? And I remembered back where in the 17 frequency polyhedrons, all of them, they set up a metric way back here when the universe first began to expand at this 17 frequency mark and then the 17 frequency mark of all the other polyhedrons. Those all contain within their structure. You have to watch my other video very briefly. A ratio, which is a very easy way to understand. The proton's value of 1836 ratioing with the neutron at 1838.5. Now I know they're currently 1838.683 neutron and 1836.152 for the proton, but remember, symmetry hasn't broken yet. So all these things hold whole rational symmetrical values. Watch my other video so you can see how these 1836 ratio to the 1838.5 to the electron is 1. So all of these are the spheres within these polyhedrons. It's very, very cool. I say to myself then, because 613 spheres are on one plane of the squares faces in these polyhedrons, and 919 are on the central hexagonal planes and the outside hexagonal planes of these polyhedrons, I said, well, what about 613 and 919? Do they ratio around anything interesting? And they ratio around the number 3,677. And they do the same type of thing. 3,677 times 1 plus 1 is equal to 3,678. Times 1 minus 1 is equal to 3,676. When you ratio this way then, they will meet up again at this number here, 6,760,164. That's interesting because that ratios in a funny way, you guys. It ratios to the neutron's mass of 1838.5 times 2 to the second power minus the mass of the electron divided by 2. And this equals, this is cool, Planck times 10 to the 40 plus the inverse of the alpha measure times 10 to the third minus the proton's mass, which is equal to that first 0 point. Now each of these 0 points that I'm mentioning, each of these 0 points I'm missing, they continue to double ad infinitum. So these number patterns between whole rational units of measurement using energy vectors, which I'll explain in a second. So just by using the vectorial count, it's amazing then that I can blow up a polyhedron like you guys blow up structures in your Large Hadron Colliders, and I come up with all the same numbers. Because I'm on a time crunch right now, I don't want to go too much farther into it, but see, some of the speculations then came from Einstein doing his math and saying, I think everything is a finite yet unbounded universe and expanding omnidirectionally. Hubble in 1929, he's studying all kinds of galaxies and spectral emission lines from them, and he's saying, whoa, these things seem to be moving away from each other and from us. He publishes a revolutionary theory in 1929. This is, of course, proven after many, many years, and then we send up the telescope, which is named after Hubble, which gives us wonderful images of those faraway galaxies that we're now studying. In Synergetics, what we're studying right now are things that are pre-time and pre-size. In Synergetics, we take time out of the equation and replace it with frequency. Frequency of interference patterning and subdivisioning and fractionation. So time is also implicit in the system, because every vector in our system is equal to what physics says. It's a mass times a velocity. And a velocity is a direct relationship to time. Please watch my other videos. I'm sorry that I'm under a time crunch right now and I can't go into things in more detail, but I'm going to be giving some more lectures, and I hope that you folks are interested. I really appreciate your time with me today. And once again, I hope that we can now at least see how, as Stephen Hawking talks about in his theory of everything, hey, we may just have to settle for all these different theories because we don't know how to unify all these numerical interrelationship patterns. Those are not his words, they're mine. Xing-Tun Yao in The Shape of Inner Space, he's the one, he says, we need a new metric, we need a new geometrical system. So I really think we might have something here, you guys. Once again, all I'm trying to say to physicists and friends in this world is that there are some really, really interesting numerical interrelationship patterns which humans are not paying attention to because they haven't studied from this 6-axis metric, which develops this harmonious means of visualizing the expansion of universe in a symmetrical, omnidirectional way that just happens to ratio all of these different nuclear considerations. Once again, thanks for your time, you guys. All right, you take care.